What's up, guys? My name is Michael Lin. Welcome to my YouTube channel. Today we are going to do a AtCoder regular contest virtual participation. Originally I was going to do this contest normally, but then I realized like it was too. I had to wake up at like 5 a.m. to do this contest, and I didn't really do it. Yeah, I woke up. I said I was gonna do it, and then I didn't even look at the problem, and I just went back to sleep. But yeah. Let's actually do this contest, and let's do this virtual participation. I know it's a really weird time to be live streaming because normally you guys I live stream at a different time. But let's see, what time is it in India right now? Let's see. Okay, it's 3 a.m. for you guys, so it doesn't matter. But I'm gonna try to live stream normally at my normal time. But for now, this is going to be the only time that it's going to be one of the few times where I live stream at a very strange, different times. So yeah, guys, bear with me. But yeah, I'll try to live stream tomorrow morning or something like that. But yeah, wait, no, tomorrow morning is another beginner contest. I don't know. I'll do something. I'll think about something. But anyway, let's do this regular contest. These regular contests are a little more tricky, more difficult than the beginner ones. So. All right, let's do these tasks. Let's see how difficult they are. Sum and product. Okay. You're given S and P. Is there a pair of positive integers N and M such that you add them, it's a sum, or you multiply them, it's a sum? I think if they're equal, because if they're equal, you could use 1 and 5, 1 times 5, 1 times 4, 1 times 4 decimals. Can we try decimals? Maybe 0. No, you can't multiply by 0. Let's see, 3, 2. 3, 2. 3, 2 works because M is equal to N times M. And that's because N times M is 1. So if one of them is a 1, isn't it only possible if the difference is 1 then? I don't know. Let's find out. Let's actually try that. Okay, if the difference is 1. So let's say it was like 2 and then, so this is 3, 2, right? 3, 2 works because 3, 2 works because N is 1, M is 2. So then you get 1 plus 2 gets you 3. And then 1 times 2 gets you 2. But let's say it was 2, 3. Would 2, 3 work? 2, 3 would not work. 1 times 3 would not work. Yeah, the 1 times 3 would not give you, 3 times 1 would not give you anything. So yeah, 2, 3 doesn't work. I think it's only possible if N minus M is equal to 1. I could be wrong though. Could be wrong. So let's actually try it. Let's try it. This is just another problem. Let's try it. Let's just see if this works. I could be completely wrong. But hey, 4 wrong answers. Okay, so let's see how many wrong answers we got. Not much actually. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so the -1 does work for some cases, but it doesn't work for others. So let's see what scenario can it not work. Okay, let's draw this out. Let's draw this out. We are going to draw this out and try to get this to work. Tomorrow I will definitely do the beginner contest though. Maybe today I'll do the LeetCode contest, because LeetCode has some contests at nighttime, so that might be more suitable for me. But I don't know. We'll see. Okay, so let's see. So we're given S and we're given P, and n plus m is equal to S, and what was it? N times m is equal to P. So let's try to subtract. Let me think. Must be a relation we could get from here to here. So if n is equal to S minus m, so let's plug that in here. N times S minus, oh wait, whoops. S minus m times m should equal to P. So that gives you Sm minus m squared is equal to P. Could I get somewhere with this? Could I get somewhere with this? You probably cannot. You can move this to m squared minus Sm plus P is equal to 0. So yeah, I don't think I could get anywhere with this. Positive integers such that you could subtract and add them up together. Let's see. We got to keep thinking. Let's see. What if you take P over M? P over M. So N is equal to P over M. So let's go back. N plus M is equal to S. So N plus N, S, N times M is equal to P. What if we do N is equal to P over M? We plug this into here. P over M plus M over M. Oh wait, M squared over M is equal to S. M squared plus M is equal to Sm. That's the same thing what we said the other time. M squared plus P is equal to S times M. I don't know. Let's keep thinking. We got to keep thinking, guys. Let's see. What other scenario does this work? There is no such pair that N minus M. Okay, we know M and N cannot be 0, can they? Wait, if P is 0, all of them could be zeros. Right? Oh, maybe that's a test case. Hold up. Oh, this is supposed to be S and P. My bad. Let's see. 0, 0. 0, 0 is no. Okay. Okay. So that's definitely a test case. This is supposed to be S and P. Okay. Or S and P were both equal to 0. If P is equal to 0, you could say 0. No, if S is equal to 0, right? One of them has to be 0. M could be a 0. So technically, either S or P could be a 0. They don't have to be both zeros. Wait, okay, so if S is 0 and P is 2. No, that's impossible. No, that is possible. So if S is 0, then that means these two are negative inverses. So that means that this is not possible. But if P is 0, one of these have to be zeros, N and M. Which means that N plus M must be a 0, which means S be any number. If P is 0, S could be any number. Right? So as long as P is equal to 0, or P is equal to 0. So or P is equal to 0. Let's try this. AC, a wrong answer. Okay, which one is wrong answer? How many did we get wrong? 1, 2, 3, 4, 5. Okay, so we have 1, 2, 3, 4, 5, 6. Oh, we still have 6. Okay. Huh. Okay. Is there a pair of two integers such that they add up and they multiply is equal to P? If you multiply P, if P is 1, let's say P is 1. If P is 1, let's say P is 1. N and M are opposites then. M plus 1 over M. S cannot be just anything. I'm still trying to think. S and P. Does there exist two numbers such that you add one of them? Okay, we might be able to brute force this actually. Let's see. Okay, let's keep thinking. N plus M is equal to S. N times M is equal to P. N plus M is equal to S. N times M is equal to P. S is equal to N plus N. Hold up. N is equal to P over M. What if I do N is equal to N? M is equal to N, P over N. Then I put this here. Then I get N plus P over N is equal to S. Let's see. Take N squared plus P over N is equal to S. So that means N squared plus P is equal to Sn, which means that N squared minus Sn plus P is equal to 0, which means that S can we brute force the factors of P? Try to factor this. Let's try moving. Okay, move P to the other side, negative P. N times N minus S must equal to negative P. Unless we keep trying different types of N values, and then we'll be able to get it. I think maybe the answer is just N cannot be equal to 0. M cannot be equal to 0. We know that for a fact. N cannot be equal to 0. Actually, can it? P is 0. N, M, they all could be zeros. They're both zeros. They all could be zeros. You just can't divide by it. Both zeros. If one is 0, you just have to make s equal to the original number. Whoops. Let's keep thinking. Keep thinking. Keep trying. We just have to keep trying. We're gonna get somewhere. Roots of quadratic equation. Yeah, that's what I was thinking. N squared minus Sn plus P. N squared minus Sn plus P equals 0. I just destroyed my pen for some reason. No! What are the possible roots for this? Let's see. Okay, how do I... What are the possible roots for quadratic equation? Is it determinant? Discriminant? B squared minus 4ac means no real roots. B squared minus 4ac. B squared minus 4ac. So if B squared, S squared minus 4, 1. So if B squared. So if S... B, okay, so negative S squared minus 4 times 1 times P. If that is less than 0, that's no. I think that's right. So if S times S minus 4 times 1 times P, so 4 times 1 times P, so that'll just be minus 4P, is less than 0, then just print out no. Otherwise, print out yes. Maybe this will work? Wrong answer. Okay, what are we getting wrong? 1, 2, 3, 4. 1, 2, 3, 4. Well, we're doing better than before. There is one real root. One real root. There are 2 real roots. Less than or equal to 0. Is that it? Whoops. Maybe that is it. We try that. Two wrong answers. We're getting close. We're getting so close. No, we got more wrong answers. 1, 2, 3, 4, 5, 6. Okay, that's not right. We got more wrong answers. B squared is S squared. S squared minus 4 times A, which is 1, C, which is P, is equal less than 0, then it's no. Otherwise, it's a yes. What are we doing wrong? No such pair. Let's try 1,000. Let's try 1,000. Let's see. Let's see. All right. Ah, this gives a yes. So this is wrong. This is wrong. So why is this wrong? This should give a no. So let's try it. S squared minus 4a. A is n, which is 1. C is p. Ah. Okay. Let's go back. Let's see. Let's go back to the quadratic equation. B squared minus 4ac is no real roots. 4ac. B squared minus 4. B squared minus 4ac minus 4a. A was 1. C is p. There's no real roots. There are 2 real roots. No real roots. Okay, how do you do this? How do you do this? Keep thinking. B squared minus 4ac. B squared minus 4ac. We're going to get somewhere. For B squared minus 4ac. See something. Greater than or equal to 0. If it's greater than or equal to 0, then it's a no. Isn't that exactly what I said here? You're saying if it's greater than or equal to 0, it's a no. Are you sure that doesn't really make much sense though? That means there are real roots. No, I get more wrong answers. Yeah, I don't think that makes much sense. Let's see. Let's keep trying. Let's keep trying. Greater than or equal to 0. Greater than or equal to 0. C. B squared minus 4ac is greater than 0. 4a. A is 2. Let's see. B squared 4a 1. C, which is p. Let's try something else. Okay, let's go back. Let's try. I completely damaged my pen. How did I damage my pen? No. Hold up. Let me try something. Oh, now it's working. Okay. So b squared. Okay, let's try this. 3, 2. 3, 2 gives a yes because 3. P is equal to 2. B squared is, so let's see. Let's see, n squared. So n plus n is equal to 3. N times m is equal to p. So let's see if we do. Let's try moving things around. Okay, let's try. Let's try doing things in terms of m. Yeah. Okay. So m is equal to p over n. Okay. Let's plug this back in here. M plus p over. Oh, whoops. P over n is equal to p over m. Plug this back in here. M plus p over m is equal to 3. Let's try this. M squared plus p over m is equal to 3. So let's do m squared plus p is equal to 3m. So if we move both things on both sides, m squared minus 3m plus p is equal to 0. So b squared, which would be minus 3 squared minus 4m a1c would be 2. This is greater than 0. 9 minus 8 is 1. So it's not, so it will give you yes. I'm still trying to think. It's very hard. It's very hard. Hard stop. 4 times 1. B squared minus 4ac. Negative b? Maybe it's negative b. I don't know. But that just doesn't make much sense though. B squared 4 times b squared minus s squared. Okay, let's try that. Let's actually make this less than 4p. See if this works. Keep trying. Keep trying. Yeah, I know that. Add square root of b squared mod by 4 is equal to 0. What? See, the thing is, if you brute force, I don't think that you'll get TLE though. That's the thing. One, two, three, four. See, I did put less than or equal to 0. Then that'll be no. I already tried that. We could try it again. Yeah, it's still wrong answer. In fact, I got more wrong answers. Now, if you're saying like greater or equal to it and then put yes, that's essentially the exact same thing what I put before, but then just in a different light. Like that's just what I put in originally. Let's keep thinking. Right, that's still a wrong answer. Let's see. Yeah, that's exactly what I put before. 1, 2, 3, 4. Let's see. S times S is greater than or equal to 4 times P. Let's see. S times S is greater than or equal to 4 times P. Mod by 4. Let's see. 1, 2, 3, 4. We're very close. We just have to get 4. Mod by P is equal to 4. Greater than or equal to 4? Let's just keep trying.
You want a Big Mac or chicken sandwich? Chicken sandwich or fish?
Chicken sandwich? I don't know.
Okay.
Yeah. Okay, let's keep trying this. Okay, let's try this. Keep trying. Just keep trying. Keep trying. Just keep trying. We're going to be able to do this, okay? So this is yes, but try modding by 4. Mod by p, check if it's greater than or equal to 4. Huh? Would that work? I'm essentially doing the same thing, but... Aha! I think we got something. Two wrong answers. Nope, that's way more than one wrong answer. 1, 2, 3, 4, 5, 6. Okay, it's not mod by p. Mod by 4 is equal to p? Greater than or equal to p? I mean, I'm just going whatever the hell is possible at this point. Let's see. If this is a real contest, I would get like so many points deducted by now. Like I would just get like deduction. Wrong answer. Wow. What'd you know? No, I only got a few right. Let's see. Then he will solve. X, Y, if you could prove it. Brute force until x squared is less than or equal to p is log of n solution. I mean, okay, we could... See, the thing is that if it's brute force, we have to make sure we pass the right cases. And if you're going to brute force, you have to start from 1 to what? 10 to the 12th? And we could try. And we could do it. Well, what number would you plug in though? Well, what number would you plug in? Your n and m? If m times m if m plus p over m is equal to s, then print out true, otherwise print out false. And we could do that. One e to the 12th, is that what it said? Yeah, 1e to the 12th. If... Okay, this is going to be our m. And this has to be long. If m plus p over m is equal to s, then we see out yes, and then break. Otherwise, we see out no. Make sure these are parentheses, and then make sure this is parentheses with that. Let's try this. Although I think this would get TLE though, but I mean, we keep trying. Two wrong answers. Whoa, this doesn't make much sense. Seven wrong answers. Brute force from... I have no clue. This is going to get TLE. Oh, it didn't. It didn't get TLE. It did get TLE. Everything's TLE. Okay. Brute force m to m squared is less than or equal to p. We could try that. Because then it'll only go up to here, right? So I'm going to check if m squared minus 3 times, yeah, minus s times is equal to s. Try this. Keep going. Keep going. We just have to keep pushing. 2 wrong answers. Okay. Okay. What's the problem? We're getting more wrong answers than before than when I did it in just one solution. Okay. Let's see. Brute force from p m squared minus 3 times minus s times m plus p is equal to 0. Or we could try that. M squared minus s times m plus p is equal to 0. And we could try this. There's no harm to it. Try this. Oh, okay. Wrong answer. Let's see. Yeah, we're getting way more wrong answers than before. Way more wrong answers. I don't know. This problem looks super hard. It's the easiest. Don't give the answer though. Not nice. It's the easiest. It's the easy. I don't think the problem's this difficult. What's the next one? Okay, let's go back to problem A. We'll do B soon. When we finish problem A. 1e to the negative 7. Binary search. Okay, I see it. Oh, excuse me. B squared minus 4ac Okay, what if we do b square root of b squared minus 4ac minus b is greater than 0? That's a case minus 2 real roots. Right? Yeah. Let's try that. 4s, wait, what was it? 4s squared minus 1 times p. Square root of this minus s Yeah. Minus s is greater than 0. Let's see. Just keep trying. Just keep pushing. Still wrong answer. Why? There are so many wrong answers now. B squared minus 4ac is greater than square root of b squared. S squared minus 4ac is greater than 0. Real intercepts. Real intercepts. I don't know if two things have real intercepts. Well, I tried most of them. Let's see. Breast for us normal people takes a lot of time to improve. That's why I'm doing cause everyday study every day. Yes. Yeah, this is true. I know. For us normal people, it's very difficult to improve. Okay, I'll show your comment, Penguin. If we assume x is less than or equal to y, x squared is less than or equal to p. So we brute force until x squared is less than or equal to p log of n. I think I was doing it. I was doing that. Mod by 4. Mod by 4. Mod by 4. So if it's... I don't know how that has to do with anything. Okay, it's fine. Like, we could do that. I mean, I just don't know how... Why would you mod by 4, though? No, it's not necessarily the case. What was it? B squared minus 4p minus s. This one? Mod by 4. You gotta cast this, though. Still wrong answer. Mod by 4 didn't work. Minus 4p minus s mod by 4 is equal to 0. I mean, I could even do ceiling. It's double. Nah. I mean, normally it is ceiling, though. Could do this. I don't think that'll do much, though. How would mod by 4 work? Still 3 wrong answers. We were missing one test case. Not missing one. We had a problem with just one. Let's see, my submissions. We had a problem with there's one where we got like very few test cases problems. Let's see. Was it this one? Yeah, this one. No, not this one. It was like it was when it's greater than this one. So if it's less than 0, but I don't understand what's the other problem. So I could take this and put it back here. Whoops. We could try to find out what's the problem with this solution. S squared minus is no, otherwise it's yes. See, brute, retracted. Sorry, the contest is very difficult to study. I know, it's very difficult for us to improve. Let's see, 1, 2, 3, 4, 4-ish, 4. Wrong answer. Sample test 2 gave us the wrong answer. What was the problem? Maybe because it gave us out of bounds? Is it less than 4 times p? Is it less than 4p? 4p is 4. No. So that's why it's yes. But that doesn't make much sense. If we do... Hold up. N times m plus p... Imagine you had 3, 3, 3, 2. Okay, 3 squared. Brute force from p and p minus p. The avenues is difficult. Very difficult problem. We got to be able to figure this out. We will. I believe in you. I know you could do it. 1,000... 1, 2, 3, 4, 5, 6, 7, 1,001. It's no. Why is it no? B squared minus 4ac. Square root of b squared minus 4ac. Oh. We need positive roots. It's not just if it's... How do we count number of positive roots? Use the Socrates rule of signs to find number of real roots. Let's look at the negative root cases. First, look at the positive root cases, which is look at this. Sign flips 3 times. 1, 2, 3, yeah. So there are 3 positive roots, or 1 positive root. Either way, I definitely have at least 1 positive root. So the number of sign flips. Okay. So I think I got it. Okay, so we need to find the number of positive roots. So let's go back to here. Okay, so remember we have m plus m is equal to s. N times m is equal to p. Okay, let's solve for n. Okay, so m is equal to p over n. Okay, Plugging this back in here, we get n plus p over n is equal to s. So now we multiply square n squared plus p over n is equal to s. So now what we get is n squared plus p is equal to sn. Now we subtract n squared minus sn plus p is equal to 0. So now we have to find the number of sign changes. So we have 1, 2. Let's see. So you have to plug in your s. So you have 1, 2. We have 1 sign change. Wait, 1, 2. Wait, how do they say? Look at f of x. Sign flips 3 times, so there are 3 positive roots or 1 positive root. There are 3 positive ones, so 1, 2, 3. 3 positive roots. Let's look at us. 1, 2. So there's 2 positive roots. Find the number of real roots. If there are 0 sign changes, so there are 0 positive roots now. 0 positive roots. Check if there's sign changes. So we would have 3 squared minus n squared minus 1000n plus p, which is, what is that? I don't know. I just ran this on my PC. It's giving me no for 1001. Love you, bro. You could sleep, okay? You could sleep. You don't have to sleep. You could sleep right now, okay? Kamar, you could see. You could sleep. Okay, 4 a.m. in India. You don't have to watch me, okay? It's fine. It's fine. You don't have to watch me, okay? You are taking too very much pressure. It's simple implementation. Think calmly. You're taking very much pressure. You need integer roots also. So minus b plus should be divisible by 4. Problem is super hard. I'm trying to use the Socrates rules of signs. Positive real roots. So we have positive, negative, positive. If there's 0 sign changes, b, so there's minus x. There are no positive roots. Possible number of solutions to the equation. No real roots. Okay, how do you know? Discriminant is negative, it means no real roots. Yeah, I know that. 1 real root. If b squared minus 4ac is equal to 0, then that's only 1 real root. So 2 real roots. B minus b plus. Thinking too much. I tried the b squared minus 4ac minus b is divisible by 4. Honestly, I don't know why. I don't know. If b squared minus 4ac, I don't know. Let's see. Let's keep thinking. We gotta keep thinking. B squared minus 4ac is given real roots. You need two real roots. Two real roots. Four times b. It's greater than or equal to it. You have at least one real root. If you have one real root, it should work. I don't know. Let's see. 4 greater than 4p. I'm pretty sure this is just the same thing as what I said before. There are two, let's see, there are pairs of integers such that must be a way to do this. De Socrates rules. Oh boy, this is giving me yes when it should be false. Giving me yes when it should be false. 10,000, 1,000 squared minus 4ac. 1,000 squared, b squared, s squared, 4a. A is n. A is 1. C, which is p. P is 1. What is b squared? B squared minus 4ac. B squared minus 4ac. This is difficult. Very difficult. Very difficult. I think AtCoder is a little harder than regular. Regular is a little harder. I don't know how to count the number of positive roots. Rule of signs. There are two sign changes, so there are at most two positive real roots. See, if you rewrite the equation, you'd still get two sign changes. So there are at least two positive real roots. So that doesn't help you. I don't know. Let's keep. Damn. Okay. Let's see. Brute force from. We could try brute forcing again. Let's try brute forcing again. Okay. Find the max, whichever is the number's maximum, so S or P. And then we're going to try this equation again. And if it does equal, then we say yes, otherwise it's not. So let's find maximum. Let's see, m squared minus s times m plus p is equal to 0. We're going to make this n, actually. It really doesn't matter. N times n times n. N squared minus m plus p is equal to 0. So if this is the case, see out yes. Then we return. Otherwise, see out, no. Maybe this will work. Oh, we got a seed. Hell yeah. Huh. So it's because of checking the end time, the maximum number. That's what I'm talking about, guys. That's what I'm talking about. I think no one's watching anymore. I got too bored. Okay, we're on the next problem, guys. We're on the next problem. We got a seed. Okay, brute forcing was... All you had to do is brute force. I'm pretty sure there is a way to do it mathematically, though. I don't know. Tell me. Any of you guys did it mathematically? I don't know. We're on the problem B now. Given a string S of consisting of lowercase English letters, we can do this operation any number of times. Remove fox occurring as a string, substring, and concatenate it, the remaining. What is the minimum length after some operation by snook? What does that mean? Remove fox at the end. You could turn S into ice. Do you concatenate the rest? Oh, concatenate the remaining. So it's just... Okay, so this would just be S times... Find the number of occurrences of fox. Remove fox. And then, yeah, remove fox. And then count the number of occurrences of that. And then concatenate. So, like, if, let's see. Fox does occur as a substring. Oh, but there's a problem. Oh, there's a problem. You can't just do while. What if you had FO? Crap. What if you have what if you have FOX? Yeah, you remove. Okay, FO here. Remove fox here, then you still have another FOX. Then you can move it again. So this would give you 2. Right? But if you just go through it once and count how many FOX there are, you only remove once. Okay, so that's a test case that we have to figure out. But okay, read an N, read an S, read an N, read an S, read an N, read an S. Okay, this is so ridiculous. Okay, while there's occurs a substring s dot find fox is not equal to n position. What are we gonna do? What are we gonna do? Hell yeah, yeah, that's what I'm talking about. If you find a pair, it's yes, otherwise it's true. It's, yeah. Yeah. Yep. Now we are doing the next problem of abbreviate fox. And now the problem is that if you find a fox, you got to remove the fox. So we're going to find the fox, remove the fox. So, but we have to do this while it's true. So while we find a fox, we have to remove a fox. Remove all occurrences of fox in string. C++. The quick brown fox jumped over the dirty dog. The quick brown fox jumped over the dirty dog. Okay, we could use replace and then replace it with a space. With nothing? We could do that. Try this. I cannot replace it with nothing. Replace substring. I don't want a character. I want to erase. There's a boost library. Boost erase all. Why can't I use this? Oh, try this. Did it work? Erase all occurrences of string. Replace all occurrences of a substring. Remove all occurrences of a string in C++. There must be like a way to do it. Use this. Oh, this is what I was gonna do. The problem is like, yeah, this is what I was gonna do, but I mean, if there's like an easier method, let's just use this then. Okay. Fox dot length. So this would be 3. Erase 3. All we have to do is just check if cout s dot size. Okay. I don't know if this 100% works. So let's do 6 ice fox. What is the problem? Just keep trying. All you have to do is keep trying. 3. Okay, so that's right. But the problem occurs if you have something like this. This is a problem. 27. Oh, that works. Okay. Well, if that works also, then let's try this. Will we get TLE? We do get TLE, so we can't just erase the string. Okay, well, I mean, if we can't erase the string, then I don't know. What is live chat up to? What are you guys up to? Oh, what? We got almost everything accepted except for this, when we got TLE. it got 2,205 milliseconds. But, frustration. You ever feel frustrated, guys? Do you ever feel frustrated? Well, not quite. Let's see. I don't know. I'm not sure. I am not sure. We could count the number of F's and then count the number of O's and then count the number of X's. So if we have like no, that's not gonna work. So like if we count like F X, oh no, that doesn't work. You need to count F O X F X. You need an O here or an O here. So like this. So then if you remove this, you have another one, Fox. Or you have to count F O X O X. So then you remove. No. Move this. You have another Fox. So if you see an F, you need to count the number of foxes after the F. After the F. So we need to count the number of foxes after the F. Huh. Tricky question. Keep graph connected. Oh, this will be a fun one. When I do this problem, it'll be a fun problem. But let's see if we could finish the problem B. If you see an FOX, 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 get rid of the fox, get rid of that. I don't know. How many O's are after the F? How many X's are after the F? If we have one O before the F, so find a fox if there's an O before the F, or there's an O after the F, and there's an X and an F before the F, we could find a fox to remove. Actually, maybe this is dynamic programming. Think about it. Okay. Do we remove the minimum number possible length of the operation? Okay, let's try using dynamic programming. So we have FOX X. Okay. Let's say I find the f o x, right? Do we consider this into our optimal solution? Yes, so then we're going to add 1. Otherwise, we find the minimum. So let's say the optimal solution is of x is that, okay? Okay, fine. Hold up. So we have an optimal solution. Okay, so what is our optimal solution? If we get to the current value, if we consider it, we're going to take the previous x minus 1, 2, 3 plus the optimal solution of 1. Otherwise, we need to... No, that doesn't make any sense. Oh, that doesn't make any sense. I don't think you... Is this a DP question? Is this a DP question? That's a big question. Is it a DP question? Yes, I know. The fox. Fox. Those are the different types of foxes you can have. That's the problem. You could have so many different foxes. Okay, so you could have a fox like this. You could have a F-O-X. Wait, no. So you could have F-O-F-O-X like that. Or you could have an F-O F-O-X-O-X, right? Or you could have an F-O-F-O-X X F-O F-O-F-O-F-O-X X X. So what we're looking for is that we are looking for an F-O-F-O-F-O-X-X-X. So the number of O's, so if F-O-F-O, then we need 2 X's after the F-O-F-O-F-O-F-O. F-O-F-O-F-O-F-O-F-O. We need to find an F-O-F-O-F-O-F-O-F-O. And then we need to find the number of X's after that F-O-F-O-F-O-F-O. So this number of X's must equal to the F-O-F-O-F-O-F-O-F-O-F-O right here. So, but there must be nothing here. We cannot have an A. That will make it completely wrong. So we need to find, if we see a fox, we need to find all the F-O-F-O-F-O-F-O. Then we need to find an XXXX. Then we add. Or another thing we could find, okay. We need to find F-O-F-O-F-O-F-O, XXXX. Or we need to find an crap, what was it? F-F-O-X-O-X. F-F-O-X-O-X. F-F-F-O-X-O-X-O-X-O-X. 1, 2, 3, 4, 5. So F-F-F-F. O-X-O-X-O-X-O-X. A fo X X X X and then F F F F F F O X O X O X O X, right? So we need to count the number of F F F F F O X O X O X, or F F F O X X X X, right? Isn't that what we need? The fo. The fo X X X X X X. Okay? That's what we need to find. We need to find this. And how do we find the foe? The foe, x, 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 x. We find the foe, okay? How many contiguous foes are there? We find a fox, then we substring before the fox and see how many foes and how many x's are after. Okay? Okay, so I got it. Okay, so we don't do this. We don't want to subtract, actually physically erase it. What we're going to do is we're going to go through this string. And then we need to find a fox. So if we see a, I don't know, an F and an O and an X. We need to find the F before it, right? So this is, so here we need to find the foes before it. We got to find the foe. So if we find the foe, that'll get rid of the number of foes and the one number of x's after. So then we can do 1, 2, 3, subtract 3. Otherwise, so subtract 3. Subtract 3 times 1, 2, 3, 4. 3 times 3 is 9. So we're 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So if we find the number of foes and the number of x's after this. So now we're going to loop from x plus, if this is the case. So here what we're going to do is find num x is equal to 0. For equals x equals I plus 3, x is less than n x plus plus. We need to find the number of foes, number x's after this. No. We don't want to go to the end. We need to find the number of x's. So while this is less than, and s of x is equal to an x. Num x plus plus. Start at 0 while it's equal to less than n and it's equal to an x, we're going to increase x. Then num x plus plus. When this happens, num x plus plus, okay? And then after this is the number of x's. We need to find the number of f's. So we're going to loop from forward and backward number of f's. So we need to find the foes, number of foes. So we're going to loop from num foe. Let's call y is equal to I. Y is greater than 0. Y minus minus greater than or equal to 0. I minus 1. Okay? And now what are we going to do? We need to find the number of foes. Actually, we should I minus 2. Right? Because we need to find the number of foes. So if s of y is equal to an f and s of y plus 1 is equal to a o, it is a num foe plus plus. We got to keep doing this while this is true. So while this is true. So this, we need to put this here. While this is true, then num foe plus plus. Num foe plus plus. Okay, so now once we have the number of foes, we take 3 multiplied by the length of the moes. 3 times the length. We take the length minus the minimum of num_foes in X times number of foes in X's. So in this case, we have 2 foes and 2 X's. So we take -1, so for the fox, and then we need a minus 2 foes and the number of X's. 2 foes and number of X's. So the 2 foes, num_foes. So this is going to be the answer. So the answer starts with n. And then what we're going to do is we're going to take answer minus 1 minus minimum of num_foes and num_x's. And then we're going to take this and multiply it by 3. Because that's the number of foxes. So right, we have FFFFFFO. And we'll remove this one. So it would be 2. Remember, there's 2 foes and 2 x's. 2 times 3 that gives 6. 1, 2, 3, 4, 5, 6. So we move 6. Right? So I think that's right. Okay. I don't know why this is not working. What the hell? What the hell is wrong with this? Numbos. Moments. Okay. There's also another case, which is if you have fox ox, which is when you have ox ffox. All right, when this happens, or remember, we have to move the foe to become we got to move the, I don't know where we got to move. I don't know. I have no idea. It's certainly possible to solve the first one mathematically. Definitely, certainly possible. I believe you can. I don't know what I did wrong, but there's definitely a way to solve it. Okay. About the F's. So we have the F's and then the foxes. Fox. We have the fox. Plus equal to 3. So then if we have a fox, by the way, we just have to add I plus equal to 3, so we can move to the next 3. Because we don't care about, right? But the faux poppy faux. Okay, and then otherwise we have to think about the fox. The faux fox. The fox. I'm gonna eat dinner now. I'm pretty hungry. Hope you guys enjoy this live stream. It's an hour and 28 minutes. But yeah, we solved the first problem. Maybe I'll solve the second problem. Rate, comment, subscribe. I'll check you guys later. Peace.